Hello everyone, my name is Gulabsha Bano, a final year student of Civil Engineering, Faculty of Engineering and Technology, Khwaja Moinuddin Chishti Language University, Lucknow. I am going to present a major project presentation on the topic of an experimental study on concrete by using e-waste as partial replacement for coarse aggregate with my team members Iqbal Rashid, Muhammad Nafis, Muhammad Sabir, and Rehan Ahmed, under the guidance of Miss Asta Chaurasia ma'am. So here is the content which is included in our presentation. So first of all, here is introduction, then there is literature review, objective, material used, methodology, concrete testing, concrete mix design, results, conclusion, and at last here is references. So first of all, before starting our presentation, we will focus that what is e-waste. E-waste is an inert waste, obsolete, discarded and malfunction part of any electrical or electronic devices such as refrigerator, washing machine, computers, television, mobiles, etc. are known as e-waste. When these inert such e-waste is used in concrete to make it economical, then this concrete is known as e-waste concrete. We are using this e-waste concrete in our project. So as we all know, in today's modern world, the consumption of e-waste is increasing day by day because the use of electronic devices is increasing. So this project is deal with the study of utilization of electronic waste by partially replace it with coarse aggregate. We are replacing the coarse aggregate size of maximum 20 mm only. So we are testing the results in uh, strength results in 7 days, 14 days and 28 days. So this project is also deals with the disposal of e-waste because it is very harmful towards our environment. So we are making such an eco-friendly concrete to make the concrete eco-friendly and protecting it with environment with the effect of pollution. Next slide, that is literature review. We read some research paper, around 8 to 10 research paper about our project. Some of the research paper are mentioned here. First of all, here is Praveen and his teammates in the year of 2019. SP Kale and his teammates in the year of 2016, Amia Akram and her teammates in the year of 2019. In all research paper, we have find out then when they are replacing e-waste with coarse aggregate in the percentage of 10% to 15%, then strength is constant on or increasing. After 15%, the strength start decreasing. So we focus the main on the percentage of replacing the e-waste with coarse aggregate. So so moving towards the next slide, here is the objective of our project: to investigate the potential of e-waste as a partial replacement for coarse aggregate. Second one is to optimize the percentage replacement of coarse aggregate by e-waste in concrete by conducting tests. We are conducting test of workability test and the compressive strength test. As I told you earlier, we are checking the strength of concrete at 7 days, 14 days and 28 days. Third one is to study the effect of aggregate and e-waste on modified concrete and also to compare the conventional concrete with e-waste replacement. We are comparing the conventional concrete with our made e-waste concrete. So in our project we are making the M25 grade concrete. The ratio of M25 grade concrete is to 1:1:2. So the another objective of our project is to exculpate the cost of the construction material. As we all know, the cost of aggregate is high as compared with the discarded e-waste, because we all know the discarded material has slightly less or very much less cost as compared with the coarse aggregate. So the objective is clear, that to exculpate the cost of construction material. And the last one, to develop and improve the technology for e-waste management. Moving towards the next slide, the main material which is used in our project, that is e-waste. We are using only plastic circuit boards of e-waste in the crushed form. We are not using any electrical part of any of e-waste. And second main material is cement. We are using OPC 43 grade cement, ordinary Portland cement, as per the IS 1489 1991. And third one is fine aggregate. We are using the river sand as per the IS 2386 part 1. And fourth one is coarse aggregate. We are using the maximum size of coarse aggregate up to 20 mm, as per the IS 2386 1963. Fifth one is marble dust. We are using marble dust as an additional material, just like e-waste, to increase the strength of our concrete. And sixth one is admixture. And seventh one is water. We are using water as per the IS 456 2000. Moving towards the next slide, that is methodology. This flowchart shows the methodology which is used in our project work. First one is collection of material. Second one is testing of materials in lab. We are testing for specific gravity, water absorption test, and etc. And third one is preparation of concrete. Fourth one is testing of fresh concrete. Testing of fresh concrete includes workability test, in which there are three tests we are perform. First one is slump cone. Second one is compaction factor. Third one is flow table. After that, casting of cubes, and after that there is curing, and after there is testing of cubes. As I told you earlier, the testing of cubes takes place at 7 days, 14 days, and 28 days. And after that there is result analysis, and at last there is conclusion. Moving towards the next slide, that is concrete testing. Material testing includes sieve analysis, specific gravity, and water absorption. And workability test includes slump cone test, compaction factor test, and flow table test. These pictures are showing all the tests we have performed in the project. So moving towards the next slide, that is concrete mix design. We have made 7 mixes of concrete and compare each other with the conventional concrete. First mix is plain concrete. These data is in kg. Second mix is in which we have added 5% of e-waste. In third mix we have added 7% of e-waste. In fourth mix we have added 10% of e-waste. This is the calculated data which we have calculated to make the concrete mix. Moving towards the next slide. Uh, these are the 3 mixes in which we have added the marble dust. As I told you earlier, that marble dust is an additional material to increase the strength of concrete and boost the power of e-waste. So in fifth mix we have added the 5% of e-waste and 5% of marble dust. In sixth mix we have added the 7% of e-waste with the 7% of marble dust. In seventh mix we have added the 10% of e-waste with the 10% of marble dust. So, moving towards the next slide, that is results. This is the compressive strength which we have tested in CTM machine, compression testing machine. The first table shows the compressive strength of conventional cube and the water cement ratio of 0.45 with the slump value of 105 mm, compaction factor value 0.83, flow table value 410 mm. These are the averages of the three readings. So at 7 days, the compressive strength is 21.23 megapascal. At 14 days, 29.26 megapascal. At 28 days, there is a strength of 32.34 megapascal. Moving towards the next table, the second table is about the compressive strength of concrete with 5% addition of e-waste. In this, water cement ratio is same as in the previous table, that is 0.4545. The slump value is 108 mm, compaction factor value is 0.84, flow table value is 410 mm. The averages of strength at 7 days is 22.96 megapascal. At 14 days, 31.80 megapascal. At 28 days, there is a strength of 34.98 megapascal. As we compared it with conventional cube, uh, with first table, there is an increase in the strength with the addition of 5% of e-waste. So moving towards the third table, that is about the compressive strength of concrete with the 7% addition of e-waste. With the same water cement ratio 0.45, the slump value is 115 mm, compaction factor value 0.87, flow table value is 410 mm, as same in the previous table. So the averages of strength at 7 days is 23.61 megapascal. At 14 days there is a strength of 32.86 megapascal. At 28 days there is a strength of 35.97 megapascal. So as we compared it from previous table, there is a increase in the strength. As we already know that, as I told you earlier, the percentage, if we increase the percentage of e-waste, there is an increase in the strength. This is proved in the table that if we increase 2% of e-waste, then there is an increase of strength. So moving towards the next table, that is 10% addition of e-waste. So water cement ratio is same as in the previous table, that is 0.45. Slump value is 125 mm. Compaction factor value is 0.88. Flow table value is 410 mm. So averages of strength at 7 days is 21.01 megapascal. At 14 days there is a strength of 29.10 megapascal. At 28 days there is a strength of 32.08 megapascal. As we compared it from previous table, with the addition of 5% or 7%, there is a decrease of strength. So there is a when we increase the e-waste at 10%, then there is a slightly decrease of strength as compared with the 7% of the e-waste. So moving towards the next table, that is 5% addition of e-waste with the 5% addition of marble dust as an additional material. In this, we have take the water cement ratio 0.45, and the slump value is 110 mm, compaction factor value is 0.86, flow table value is 410 mm. So average of strength at 7 days is 24.48 megapascal. At 14 days 33.90 megapascal. At 28 days there is a strength of 37.29 megapascal. So as compared with the previous table, there is a increase in strength. As we compared it from second table, there is a increase in the strength as we add the 5% of the marble dust. So moving towards the next slide, that is the table number 6. In this there is a compressive strength of concrete with the addition of 7% of e-waste with the 7% of marble dust. In this there is a same water cement ratio 0.45, slump value of 118 mm, compaction factor value 0.87, flow table value 410 mm. The averages of strength are at 7 days is 24.91 megapascal. At 14 days there is a strength of 34.50 megapascal. At 28 days there is a strength of 37.84 megapascal. So compressive strength of concrete with the 10% of e-waste and the 10% of marble dust addition, the averages of strength are 25.13 megapascal, 34.80 megapascal. At 28 days there is a strength of 38.61 megapascal. So as we seen that there is a slightly increase of strength as with the addition of marble dust in the e-waste. So moving towards the next slide, this is the graph shown the comparison of conventional concrete versus e-waste concrete at 7 days, 14 days and 28 days. As we seen in the graph, there is a peak strength gain in 7%. The strength are 35.97 megapascal and 32.86 megapascal and 23.61 megapascal. So at 7% there is an increase of strength, and after that there is a slightly decrease of strength at the 10%. So this is the second graph which is shown the comparison of conventional concrete versus e-waste concrete and marble dust concrete at marble dust concrete at 7 days, 14 days and 28 days. In this we have seen that with the addition of marble dust the strength is increases till 10%. There is a slightly less strength in starting, and after that there is an increase of strength till 10%. So this is the third graph which is shown the comparison of conventional concrete versus uh, conventional concrete versus e-waste concrete or e-waste concrete with marble dust. These are the three comparison which is shown in the graph. Moving towards the next slide, that is why we should win. We should win because it is the one of the best method of disposal of e-waste, because we all know that e-waste is very harmful towards the environment because it contains highly toxic components just like lead and cadmium, and it is very harmful towards the environment and both living beings. It affects the nervous blood system of human beings and also have a negative impact on children. So second one is natural imbalance can be avoided by replacing coarse aggregate with e-waste in concrete production. Yeah, imbalance maintains because the disposal of e-waste is a very uh, difficult process. If we landfill, if we do landfilling, then it contaminates the groundwater. If we do incineration or try to burn the e-waste, then it pollute or emits the highly toxic gases in the environment, which is very harmful towards the atmosphere. So moving towards the next slide, that is our limitations. In our project, we are maintaining constant admixture, super plasticizer by varying e-waste and marble dust content. Second one is only M25 grade concrete cube is casted. Yeah, we are only casted M25 grade concrete. Uh, uh, Third one is conducting only compressive strength test on the e-waste concrete. We are tested only for compressive strength. We are not tested for tensile strength and also for flexural strength. Fourth limitation is only coarse aggregate is partially replaced by e-waste. We are only replaced the coarse aggregate. We are not replaced any other component of concrete. So it is our limitations. Uh, the next one is future improvement to determine economical doses of admixture for various replacement of e-waste. Second one is split tensile test and flexural strength test has to be conducted to use this concrete for constructional purposes. Yeah, these tests are also very important to be conducted in concrete to used it in the major construction purposes. Moving towards the next slide, that is conclusion of our whole research. It is observed that up to 7% replacement of coarse aggregate with e-waste there is an increase in all mechanical properties. Tables are the proof which is shown that up to 7% replacement of coarse aggregate there is an increase of strength. After 7% there is a slightly decrease of strength. So second one is when the percentage of e-waste increases up to 10%, the compressive strength decreases slightly, which is nearly same as conventional cube. As we increase the percentage up to 7% till 10%, there is a slightly decrease in compressive strength, which is nearly equal to the conventional concrete. And the third one is that addition of e-waste with marble dust shows increase in compressive strength even above 10% replacement with coarse aggregate. So when we add the marble dust as an additional material with e-waste, then there is a increase in strength as compared with the e-waste concrete only. Then this replacement is also worked above the 10% replacement with coarse aggregate. So marble dust is a good material to increase the strength with e-waste. So fourth one is strength reduces because of bonding of e-waste reduces. As the bonding of e-waste is not good in concrete, so because of it there is a reduce in strength. Fifth one is it is identified that e-waste can dispose in concrete as coarse aggregate. E-waste cannot be disposed in concrete as a fine aggregate. So sixth one is volume e-waste on earth reduces when it is used in concrete. As I told you earlier, it is the one of the best method of disposal of e-waste. So seventh one is up to 5 to 6% replacement of e-waste is suitable use up to G+2 building construction road construction. So it is has been concluded that with the replacement of 5 to 6% of e-waste in concrete, it is this concrete is used in the G+2 buildings construction and also good for the road construction. Up to 10% replacement of e-waste is used in construction where low strength required such as garden walls, construction wall, etc. As you all know, the garden walls bear the less load. So 10% replacement of e-waste concrete is used in that low strength works. Then next point is solid waste management of e-waste done when it is used in concrete. So it is also a good method for solid waste management. Last conclusion is e-waste concrete block having flexibility. It directly not fail during test. Firstly, it compress up to 1 centimeter, then break. So our concrete block have flexibility. So it is good for earthquake because at the time of earthquake some clearance in structure we have needed. So flexibility plays a very important role in earthquake. So it is good for earthquake also. So at last here is references. These are some references from where we have studied and taken some data. And at last, thank you for paying attention. Have a good day.